Yeah, good evening, everyone, and welcome to the live session on BFSI. Today with us we have Mr. Bikash, and without any further delay, over to you, Mr. Bikash.
Yeah, hi everyone. It's again a pleasure connecting back to the student community, right? And this is, I think, doing the second or third time, specifically this webinar on banking and financial services and insurance, in short, BFSI. So, hello everyone, and what should we expect from this webinar in this next couple of not couple of minutes, I should say, in an hour, is we will try to understand what is the subtle difference between BFS and I. They more or less, from a technical standpoint, from a data science perspective, they more or less have the same requirements. Just their way of business is kind of a little bit different. We'll also see what are the challenges these sectors face, and they have been facing it since a very long time. But now that we have more technology, more computative power and stuff, we're able to solve few of those problems. And still, the research is going on for solving some other. So over this, during next 60 minutes, we'll get a good introduction on these areas where machine learning engineers can prepare so that we can get a role, into solving those problems and make a career in this industry, BFSI industry. It's a very exciting industry, a lot of challenges, a lot of things to learn. Even people like us who have been in the industry in this particular area for 10 years, still, there are challenges that we don't understand. There will be areas where we do a lot of studies and research, and then we probably go with the technology sector. So in short, before we start, one liner is technology will come later. First we have to understand the problem, right? First we have to see what business problems are we solving here, and then we'll see how technology can enable us to achieve those. All right, so the first slide, what I have tried here to explain is the right? B, Fs, and I is, what does the B stand for? Is banking, which means we have the core banking that we typically do, right? We have debit cards, credit loan, mortgages, finance loan, and stuff. And also we have this corporate investments, private and retail areas, right? So this pretty much covers the banking area, and it's very common to everybody. Some doubts does occur when you talk about financial services. Is what is it like? So financial services are like extended version of banks, where we can. So for example, you have HDFC Securities, right, which lets you buy stocks and sell stocks. You can buy mutual funds, you can buy equities, etc. And you can basically invest, right? So there's like additional services that you're getting, mostly related to your finances. Then you have all these payment gateways like Paytm, CC Avenues. All this helps you transact money instead of going to a bank, right? So they are like digital banks for us these days. So they are like comes under the financial services. And then we have the insurance, where we have covers or like protections in case of any unfortunate event that happens, like medical emergencies or health issues, and those are for living things. And then we have non-living insurances, like for car, for your house, and other assets, right? Sometimes when we fly, we also take insurance for our luggages and stuff. Similarly, we have insurance for our passport, for our visa. Things can go wrong when we travel to abroad. So all those provides us with a protection, so that we don't have to pay a huge sum of money to get our passports or visa or make our life easier. Rather, we pay a small amount, and we get those benefits. So now that we understand what is the banking, financial services, and insurance, let's see a few of the use cases or the challenges that banks typically face. This is not the entire list, of course. This is just to give you, because this is an introductory course on BFSI, so this should give you a good feel of the water, that what are the challenges typically a bank faces. These are like the crux, but then once you join a particular project, you'll then have a lot to learn, and a lot of things will come up. So one of the challenge that banks face is the customers, finding new customers. Nowadays there are so much of competition that happens from you just show your credit card and they give you a suite to relax and have unlimited food. So that's the way of getting more customer. Now that I have used their services, I will talk good about it to my friends and colleagues, and probably they will go and get a credit card of that bank, and they will also be able to avail this kind of facilities in the airport. Second is tackling demand supply mismatch, right? So banks, people approaches banks for loan to start their own business, but we understand that bank takes customers' money and they invest somewhere so that they can get more money in return, and only then bank is able to give you the loan and credits, right? So it also has to follow all regulations. It has to follow all the policies that sometimes for India it is RBI. They have to set up. They have to follow some rules that they have set up, and within that they have to be profitable and they have to be able to run the business. Then we have credit risk. So bank faces a lot of challenge when somebody approaches for a credit, and they have to decide whether they should give credit cards or loans or mortgages to a certain individual or a corporate, right? Because many a times what happens, they give the money, we have seen in the news, we give a lot of money to corporates and individuals and they don't return the money. These are all technical things, and this can be technically solved to a certain extent. And coming to the next one is improving risk management. So risk again comes similar to the credit risk. There are a lot of other risks where banks are likely to invest, but they do risk assessment to see whether they should invest or not. And same thing, machine learning and data science could to a certain extent help us. And most important is the fraud detection and safeguarding customers' data. So what happens is every now and then the banks get hit by these hackers who tries to behave like a customer, an existing customer, but they are not, and they are able to exploit the loopholes that are present in banking system, and they are able to take away the money or install a ransomware or something, so that banks lose money, which has it's kind of big loss, not only for the bank but eventually for the customers. So it becomes of ultra important to cover all these areas and prepare for that. Same thing, if we take few challenges in the financial services, again, many of these or challenges that you see are very common when we look it from a technology lens, right? Banking, financial service, and insurance all sort of faces the same issue. That is the data security and breaches. If I have to provide services under the terms of financial services, we have to make sure the data is secured and the breaches are at the minimum or doesn't happen at all. That is the ultimate objective. As I told, there are issues with ransomware where hackers are able to install ransom and bots into our system, and they could be actually stealing the customer information, bank details, etc., and even put a threat on those. They can lock down the system asking for money and then maybe whatnot. And then we have this, again, same thing, credit risk modeling. Before we go to these financial services, they also do this credit risk. When we are purchasing a stock or something, they also evaluate whether it's a risky or not to sell those stocks, right? Same thing, a lot of investments decisions are to be made because data science is capable, no doubt, machine learning is capable, no doubt, but end of the day, we need hardware, we need resources, we need human developers and architects, where we should invest money, and we need to hire good people, smart people, so that they can be able to implement ML and data science. But they need hardware, they need state-of-the-art technologies to work with. So that also comes. People do invest a lot of time and research on using data science machine to find where they should actually invest. So there are a couple of banks who have done machine learning. They have put machine learning algorithm to figure out how much hardware they would need for during this big billion-day sale and stuff and so on. Similarly, all financial services also have to follow industry regulations and government compliances. This is again common for when I say them, so it means among different financial service providers. So when new technology comes in, one or the other company will be first to pick it up and start using it, and there will be pros and cons. So all people have to, kind of, even not by choice, they have to pick up new technologies and start working with it. So that means they have to invest money in acquiring those technologies and getting more resources. That means expense. So that's again a huge competition out there. And then every day in any kind of banks, nowadays we talk about petabytes or exabytes of data, right? 10 to the power 12, 10 to the power 15 bytes of data to be processed every day. And we, no doubt, we are collecting so much data every day, but then we have to utilize that data somehow so that we can find new revenue opportunities, right? Either we are trying to understand customer behavior, or we are trying to understand is there any kind of pattern which all customers are probably using, and maybe utilizing that as a fact, we can launch new product or new services. Next, if we look at the few challenges of the insurance sector, again, whenever we approach an insurance agent, sometimes the premium is too high, and it might upset the customer, and they might choose another insurance provider. That's actually a very challenging area of insurance sector. So again, you can use machine learning and data science in conjunction with understanding customer behavior. In later slides, we'll see how interesting things these insurance agents do in order to gather more data so that they can make their pricing more customer friendly and affordable. Second thing is, again, insurance agencies are trying to spread their arms in the rural areas. Then there are different challenges, not just the money. The challenge are also to educate people in rural areas that why they need insurance and stuff. That also comes under what kind of analysis they can do, so that in a simplified way they can explain it to the rural areas that why insurance is very important. Deciding competitive pricing, again, which I have already explained, that if for a certain, for example, you have a car and then you want to go to an insurance agency, you will see that the premium in a typical city like Pune, the insurance price might be ranging from 15,000 rupees a year to somewhere around 25,000 rupees a year, right? Now, these insurance agencies usually tries to play a trick, and they will say, okay, you take the lowest premium cover, but then we'll be only fixing your car once or twice a year, and beyond that you have to pay 50% or more. And if you go pay 25,000 rupees a year, probably they will say, no matter how many times you bring your car to the garage, we'll do it free of cost. But then there has to be a fine line where they have to draw, saying that, okay, these are the benefits we'll give for this amount of. Now, why do they have this kind of challenges in the pricing? We'll see later in the slides that because of the competitive nature, because insurance is something very unpredictable area. They don't know how many people at what time will be start claiming their money because of something. So they have to keep the money ready, right? And so that also limits their choice of how much they can invest so that they can make money out of it. So end of the day, it's a sum zero kind of project where they have to be very sure that the summation doesn't end up zero for the company, otherwise they learn out. Second is creating better and customized services for individuals. Again, every insurance agency have few services and product listed in their offerings. So they have to make sure that they are able to better serve the customer, otherwise the customer might switch to another competitor. Same thing as you've seen in for financial services and banking, all insurance agencies has to follow government policies and regulations. There are agencies which measures, otherwise insurance agency could have monopoly. So where now government comes and sets policies for them as well. And again, the problem in insurance agencies also collect a huge amount of data, and trying to find new revenue opportunities, they have to tackle the big data, which means, again, going back to the same, you have to invest in hardware, you have to invest in resources. Anything we do, there are costs involved, right? So this is an introduction for BFSI, and what are the common challenges that people try to solve, including us, that we do in the bank, is what I have listed down here. This is not the entire but these are the high-level view of the kind of work that we do. So do you have any questions so far, so that I can respond to it? So yes, so Suman, you have mentioned about operation risk, right? So there are a lot of operations related things that happens in a bank. Okay, so most of the time we as a customer only see from the front side, right? So suppose I lost my credit card, say for example, and what happens is I call my agent and say that, hey, my credit card is lost, can you issue me a new one, right? Now what happens is I as a customer can only see that, okay, I placed a request for a new credit card and after say 2 weeks I receive my credit card, right? That's all I get to see. But in the background, what happens is the moment I submit a request for my credit card has been lost or something, the first thing most likely a customer agent will do is will check if there have been any transaction between I said the timing when I lost it and the time when I called or reported, whether there has been any transaction or not. If not, or if yes, in both cases they will block my card, the first step, right? That involves obviously technology. Second thing is they will check between blocking my card and having a conversation with me, they will check whether I'm making a fraud claim or not. Maybe I got the credit card of my friend and I want to play a prank on him, just kidding. But that is very possible that I can call on my friend's behalf and try to block his card to put him in trouble. So they will try to verify one way or the other by either by asking few passwords or some way to verify I'm the correct customer talking about the correct credit card. So those verifications, and that it all comes under the operation risk. I could somehow even have those information because I have a close friend, so I might know those answers. So they will try other way of confirming. Either they might send an agent to my friend and call that person directly with the registered number and try to sort it out that way. Say everything has been sorted out, now they have to place a request with the vendor. So banks don't manufacture these plastic cards, those credit cards, right? So they have to talk to the vendor. Now those people who the vendors are, probably they can, because they are the manufacturer of the card, they probably might figure out a way so that they can introduce some kind of fraudulent method to detect customer data out of the card, right? Because they are manufactured by them. So basically when the card gets from vendor's place to the bank site, we have to run a lot of fraudulent checks on those credit cards which have arrived to make sure that the card doesn't have any default, doesn't have any loophole. So that is again taken care of. Once that is done, an entire customer journey is produced. That whether these steps have they missed anything or not, whether the balance that the person had, the details that the card should have, are they in place or not, are they accurate or not, are the numbers updated or not. So all those things takes place in the back end, while we may be totally ignorant at what's going on in that area. Okay, so Kumar, can you make us familiar with the technical terms of insurance domains and basic technical workflow? Kumar, when I will continue with the session, could you please elaborate what do you mean by technical terms when you call about insurance? That would be helpful for me. Okay, so going back to the slides. Let's see different use cases where we can use data science and machine learning. The first thing is the fraud. The fraud will always take the top notch because we are very particular about customer data, because once that customer data is lost, we basically will lose that customer because that customer have lost trust in the bank. So how do we predict whether there has been a fraud or not? One of the examples that we use is if we see any unusually high transaction in a very frequent term. So for probably, whenever there is a card loss, we have seen that whoever has stolen the card, if it is a case of a stolen case, then what happens is people will immediately try to take out money as much as possible. So if you realize in India, we have a limit. Right now you can only take out 10,000 rupees in per transaction, right? But say you need 1 lakh rupees. So what you will do, if you don't have the time to go to the bank, you will do 10 transactions in 10 attempts, right? And from an ATM. That will keep sending SMS, emails, updates to your registered number. So if somebody has stolen it, somebody also somehow knows the PIN, but the phone probably is with you, you'll immediately come to know after first or second transaction that somebody is trying to use your ATM card or debit card. Now, in the back end, there is actually an automated process that after 3 or 4 such transactions, they might even call you to confirm that you are yourself doing the transaction. Else, if it repeats, they will probably block your card temporarily and will not make that transaction go through to safeguard the customer. They probably will call you and then release it again. That has been a very common strategy to do that. Now, from a technical perspective, what are the things that you should learn is how to relate these associations between your data and the outcomes, right? Whenever we talk about fraud, then you need to understand how do you associate something with fraud. So probably you have seen that there are some spiders in your web crawler, and you don't identify those bots from your services. So that definitely somebody else has tried to use some kind of web scraping or some kind of bots in your server so that they can collect customer information. You need to understand clustering, which is an unsupervised learning method, because sometimes we might not even know what a fraud would look like, right? So you have to use, we use clustering typically to see if there is any pattern that we could not identify as a human, but our algorithm still shows that, okay, see, you definitely see a pattern here, then we send it to our human domain experts so that they can analyze and see. You have to learn about forecasting and classification. Classification again is like yes or no, whether this is a fraud or not. So we'll come to the technical section as well, like what are the libraries that you should be having good knowledge on. So just in a brief, I'll say that nowadays the state of the art goes with XGBoost library. So if you're doing machine learning, just make sure that you have a good hands-on practice with this library, XGBoost. You should definitely learn about linear regression, logistic regression, random forest, ensemble methods. There are many other methods, decision trees, and so on. But state of the art is with XGBoost library, and we also call them GBM methods, the gradient boosting methods. So make sure you keep practicing them. They are even better than your SVMs and stuff. So if you're new to the industry, don't worry about too many algorithms out there. Learn the basics of all this, but try to use the XGBoost library if you're doing machine learning. Next comes the customer analysis. What we try to do is we try to predict whether this customer is going to be profitable in our long-term relation with the customer. We also try to understand their like and dislikes, their search behavior on our website. We would like to predict what kind of products they might like. Either they need a credit card or not based on their transactions and based on their bank statements. We try to predict probably this is a good customer to introduce a credit card because that person pays and have generalized linear models works. But then again, I told you the libraries that I mentioned pretty much does these things for you. Classification and regression trees, CART as they're known as, nothing but decision trees. CART sometimes you'll mostly see in R programming and in decision trees in your Python library. So, but more or less they do the same thing. Then we build recommendation systems. When, for example, say 1 lakh people uses a loyalty program within a bank, and I have identified what kind of customers are using those loyalty programs, and then we take those customers' details, and then we try to match it with our existing customer who haven't yet been part of the loyalty programs, and then we try to recommend them through either through SMS or maybe bank statement or through a mailing list, etc. Whatever way we can communicate with them, we try to promote our loyalty programs to them, and because that helps the bank to make more money and in return give them some loyalty rewards. One very important area which I personally work is on the customer feedback and complaint analysis, because every day there would be thousands and thousands of customer feedbacks and complaints related to a service or product. And why a particular customer is facing so many issues, and probably they have left a text message or an email or a comment on some Twitter and something, and we need to take those data and see what actually the problem is. Is it the problem with that particular customer, or are there many other customers who are facing the same issue and which should be brought immediately to the attention of our higher management and people who are taking business decisions and so on. So in those areas, we use natural language processing based solutions. So if I tell you this example, if, for example, we have 12,000 legal documents which we have to manually process, probably it takes around 360,000 hours of manual labor, which is a huge wastage of, or I should say, not properly utilized human effort. Rather, these kind of activities can be converted into a machine learning problem and can be solved in few hours and save the human resource and the productivity. We have built a lot of chatbots. We have call center automations. Many times we have seen that there is a chat applications and somebody would personify that chatbot and say that, hey, I am Bikash, how can I help you? Trust me, 90% of the time those are chatbots, not a human actually talking to you. Those are automated responses that we have built. We have implemented artificial intelligence to predict what responses to be produced based on the question type. And we have seen around 80% of the time we have been able to help the customer through a chatbot, not even involving a human person. If there is anything which the chatbot cannot understand, what we do is then we ping someone as the human who can actually read and understand your problem and help you out. Let me see if there is any question from. Okay, for what challenges listed out for banks, we have solution already in place and that can be just reused. Yes, so as I told you, right, for the fraud detection, we have a lot of algorithms in place where we see the number of frequencies of high transactions, high value transactions. And if it goes beyond a certain threshold, we would temporarily block the card of that person and give a call. That's as simple as that. Now that is repeated for any new customers that are in the bank. So that can be just reused. All banks have a different way of implementing their solution. So I am not I'm not qualified enough to actually explain what one bank is using versus another bank. But what I can say, what we have implemented is something like, if there's beyond a certain value, say if I take US dollars, so if somebody is transacting 20,000 US dollars, like happened like 4 times in a row within a 1 hour, then probably says that something is wrong. It might not. People might actually be doing that transaction, which is fine, but we then temporarily block and immediately call that person and say that if you're doing this transaction, please confirm, and then we can release it. Sometimes it's good to block rather than go with false positives, thinking okay, it might be people, so it's better stop and then confirm. There are also many methods that are already in place and we keep repeating is the credit risk model. So we have algorithms in place where we enter the person details, their insurance, their income, their age, are they married or not, do they smoke or not, because those things also have influence on their ability to return money. If we can sense that the person is addicted to alcohol or something else, we might be doubtful to give that person some credit or loan. That is why even insurance company asks whether you are do you smoke or not, because that gives some indication that you might have issues with addiction and stuff. Also, nowadays we use also local crime data to find whether there is any reported case against you, any drink under influence, DUI case against you or not. Then banks probably will not give you loan because if you drink and drive, chances are you might hit a car or something, and you might spend more money on getting those fixed than returning the bank's money. So banks use those kind of existing models for all customers, most of the customers, so that we can safeguard banks' money as well. Okay, let me see any further questions. Okay. Okay, Suman has asked, for large document analysis, do we have any ML algo other than NLP? Okay, just to tell you this, natural language processing is more still on a research mode, okay? And we do not have any one size fits all kind of algorithm. So even for example, if I take the credit card data and try to do customer complaint analysis using NLP, so typically we would use term frequency and inverse IDF algorithms, but that is not, if it is applicable in this problem, may not be that is applicable in another one. So there is no standard algorithm. So even all banks collect their data in a different way. and the analysis could be totally different. So yes, we do have term frequency, we have hierarchical clustering for complaint analysis, but that doesn't mean that all problems will be solved by that way. We also have a latent Dirichlet allocation. In a short, it's called LDA. So we use LDA methods as well to understand. So you made a complaint and another gentleman or gentlewoman made a complaint. So you want to see how closely those two complaints are. Are they about same thing? So that kind of analysis we do using LDA. But again, as I told you, all problem statement probably will invite different algorithms to be used. So we don't think first from an algorithm perspective. We first of all, as a manually, if I have to solve something, that's how in the bank we try to decide. So we have a team of machine learning engineers. I lead one of the team. There is another team who would be coming in and helping us with, and we'll see if we have to solve it manually, how would we have done it, and is there any existing algorithm? If it is there, we can use it. If it is not there, and if it is very important, we probably build a new algorithm for ourselves. So knife base is one of the common method again used, although not very efficient, but then sometimes we might have to go with it. Even it's better if it gives 60% efficient on that. So if it doesn't answer your question to the satisfaction, just let me know. I'll try to give you more examples. So for now, we'll continue with the slides. Again, coming to the financial services use cases, yes, we spend a lot of time, resources, and energy on finding spending behavior. So you might see in one of the articles recently, we have launched a service in the UK which says that whether a person is addicted to alcohol or not, just by looking at his or her expenses from the credit card. If too much of money is spent in alcohol and other that kind of drinks, we will try to notify them that you are getting used to this and you're probably picking up a bad habit and stuff, so that you can stop. So it's kind of like a community service that we are doing from the, so that kind of analysis can be also done depending on using the studying the customer behavior. Credit worthiness again is another thing. Again, from your transaction, we can see that probably you're shopping every other day from Amazon and you're not realizing that that could be also an addiction. Not that always physically harmful thing can be an addiction. Sometimes people, we have seen many people in our transactions that they keep purchasing everything from Amazon every other day. And that is also a kind of addiction nowadays. We have portfolio management where somebody have a lot of money, but they don't know where to invest so that they can grow their portfolio. So there are risk we call it robo advisory, and we have machine learning algorithm already in place which can take your portfolio, will match with other people who have gained a lot of money through properly investing, and then we try to apply the same model with your money so that your money and your investment can grow. We also try to see the impact of so you can see there are websites where people would make news that they're selling their company or something, and that could send a ripple in the stock market, and based on that there will be ups and downs in the stock market. The FMCG product prices might go up and down. So this kind of things are also comes under automatic trading. So based on the news, based on the trends, based on the market developments, how much it is going to influence your stock prices can be also predicted. Similar to banks, again, financial service also uses data science to anticipate churn. So, and we also do cohort analysis. And what is the difference is churn means somebody is using HDFC securities to purchase, say, stocks, but then we might have realized that ICICI is probably giving us better options. And okay, I'm not entitled to any of these services, HDFC or ICICI. I'm just using this as an example. Cohort analysis is also done by companies to see which product is actually doing more businesses. It's more like a Pareto analysis to find out what are the actual attributes, what are the actual services that bank is offering or insurance company is offering or financial services are offering, because of which customers like that product or may not like that product in both cases. Fraud detection again comes here. It's very common application of machine learning in financial services area. We take a lot of social media data to find new product launches, new services, or we might also change our policies. If we have seen millions of tweets that they don't like a certain policy, and we see whether it is going to impact our business or not. If it is not, we're happy to change those policies. High speed algorithmic trading nowadays is a reality. As we said, humanly, if we have to sell and buy stock, it will be a very slow process. It also said that by the time a computer screen, the light from your computer screen hits your eye, the price of the stock has changed, right? So basically, you need a high-speed calculators which can decide whether they should retain the stock or they sell it out or they buy new stocks. As somebody asked, improving on operations, yes, reducing time required to open individual or corporate accounts is one of the very common examples where we use data science and machine learning to speed up the process. So as a customer, an individual, I need a bank account today to make a transaction tomorrow. So I don't want my bank to take 2 weeks to validate myself and then give me an account. Rather, I would want some processes to be automated so that they can quickly verify my credibility and they can give me a bank account as soon as possible. Same goes with corporate accounts. Take longer time because they have too much to validate and stuff. So some of the things could be automated and the time can be reduced. Again, when we talk about this kind of services, we have to deal with petabytes and exabytes of data, and in sometime down the line, down this year, maybe we would even use more data. So it's good to have experience with NoSQL databases. You have to understand how in Hadoop. I would rather say not Hadoop, because in many places we have seen Hadoop distribution is not a fit. So you might want to explore the big data, how people are handling unstructured data and so on. Okay, and because this webinar is not to focus on how we handle big data, but just to get started as a beginner, I think Hadoop should be a good point of view to start. Next, we would see a few use cases in the insurance area, and I will quote one interesting example is, there are a couple of companies who are trying to predict that how many days a patient would spend in a hospital and compare it with the actual claim when somebody has submitted. So somebody said that, I stayed in the hospital for 15 days. This is the expense, and the insurance company has to pay it, right? But in reality, the patient might have stayed for 2 days, but have filed a claim for 15 days worth of money. So the insurance companies are trying to actually predict that whether how accurate the claim is. So I'll just take an example. In 2016, around 125,000 fake claims were submitted, and which was valued around 1.3 billion pound. That's a lot of money in that industry, and that was in 2016. Probably people have figured out more trickier ways to submit claims in 2018 and probably in 2019. And we might have to make our algorithms more smarter, more versatile, more robust, so that we can track this. People also, insurance company also spend a lot of time and money to, as I was telling in the previous slide, some auto insurance company uses pay as you drive. So they have monitors in your car, and they also track how carefully you drive, right? So they call it pay how you drive prices for their auto insurances. So that is to the extent, sometimes people who just rash drive, they meet with an accident and they file for a claim. To a certain extent, yes, it's a customer's right because they have taken insurance, but it also shows that if the person is a careless driver, more often than not, that person will meet with an accident, and the insurance company have to repeatedly pay for his, rude, rash driving and stuff. So this kind of that's crazy. This kind of systems are also in place, put by a lot of auto insurance company. Price optimization, as I was telling you, it should not go beyond the threshold of customer sensitivity, right? People are willing to pay only to a certain amount, and it should not be much more beyond that. If it is, if I expect to pay this much and the price is around that much, I would be more loyal to that particular company or insurance agency. Customer segmentation is also a very important use case in for data science and machine learning in insurance area. So depending on the financial sophistication, age, the location where that person is, and many other factors, the product offer and prices and benefits can be estimated. We might give you an insurance for a low premium, given that you have a very good track record and good credit history and so on. Property insurance company, as I was telling, also happen to use moisture sensor for leaks and flood detection, utility and appliance usage. Nowadays we have smart fridge, we have smart washing machine. So they would use those data to provide you insurance for your home, for your property. They would check your security cameras. They will sensor. They will use sensors to track how many people were there, what kind of activities were there, whether you are lighting a fire inside the house or not. So those kind of data were also collected in conjunction with local crime to make sure that they are trying to provide you as much as benefit, but not jeopardizing their offerings. Life and health insurance companies, they happen to study your customer behavior by checking what and where, what kind of food item, your media. They will also study your tweets and public posts from your Facebook. And as I've written here, you might already think that's crazy, but people and insurance companies, they happen to do all those things to figure out and get more data to understand your behavior. This kind of data typically, if you have a good knowledge on MongoDB, could come useful to store and retrieve such information. And many of the apps nowadays have this MongoDB in their backend to collect the data for that. So it's a good idea to have some knowledge about how to work with MongoDB. When I say MongoDB, I don't mean specifically as MongoDB, but I would rather say database can handle. Once she returned from her holiday, she found that one of her insurance has been canceled, and that insurance was related to depression. Okay, now she was stunned because why would the insurance got terminated? It turned out that that company who was giving the insurance told that she is not depressed because we found a photo of her in Facebook where she is smiling, and that became a huge issue in that industry. So what I am trying to say is machine learning and data science, can we find anything that is not correct? Okay, we have to have human intelligence somewhere. Not everything under machine learning or artificial That's why I mentioned this article. You can just Google this. It's a very interesting and funny article, Quebec's Natalie Blanchard, and that shows that how machine learning and data science might fail. Also, a professor at Berkeley, Edmund Berkeley, said that most problems have either many answers or no answers. Only a few problems have a single answer. So your data science might give you an answer, but trust it with a pinch of salt, right? It may not be correct. So whenever we build our data science solution, we probably do hundreds of peer reviews just to make sure that we are not just doing guesswork, right? We are actually finding patterns, and that is validated, and we run it through a lot of experts, a lot of domain knowledge, SMEs, and so on. Just by seeing few pattern, we should not conclude that this is actually the relationship. Sometimes it could be a correlation and may not be a causal effect. Is there a way of many of these insurance company have to answer this kind of question, that is there a way to find the likelihood of an insurance holder dying with a certain period, right? I think that's very sad to ask this kind of questions, but the insurance company has to deal with this kind of questions. What percentage of funds can they keep aside for future benefits? So insurance companies say that you invest 10,000 rupees a month and we will give you 1 crore, if certain event happens. But where would this money come from? So basically, there are hundreds and thousands of other people who are also buying that insurance, and collectively, not everybody will face an issue in their life every day. So the understood is only a fraction of people will face this, and they have to give the money to them. But they have to be very good with their prediction. If but nobody is stopping that not all the people will have an issue. That is, of course, that is highly unlikely, but it could. Nobody knows. So insurance company will see that they always struggle to give you the money back. Coming back to the next slide. So now that we have discussed all about BFSI, we should not be all the time trusting our data science solution. Rather, we have to validate not just once or twice, but many more times. And before we are able to do all of this technically, these are the few things I would encourage the listeners to study. Commonly, the similarity measures. Similarity measures is to like Euclidean distance, cosine distance. These are very helpful whenever you are trying to correlate two items, right? Then you have this principal component analysis, because we are dealing with big data which also have multicollinearity, which means many features could be equally responsible for a certain event, and we don't want that kind of collinear relationship. We want to rather have only one of them. A common example is if I have two features, and one is say distance in kilometer and one other is distance in miles, they are related because 1.6 kilometer is 1 mile. So I don't need both the representation of a number. So that's why it's called multicollinearity, and I don't need them. I want to remove either kilometer or mile representation of my data. Data mining techniques such as k-means, as I was telling, you need to be familiar with clustering with unsupervised. You should be knowing why support vector machines work, decision trees, ensemble methods. But as I was telling, all these methods had a very good run. But nowadays we have seen that gradient boosting methods are much more superior. So focus on practicing XGBoost library. Similarly, we have to learn about cross validation, because we don't want to just randomly guess. We want to validate that our algorithms are behaving as we expect. We have regularization, which again similarly reducing the number of features. We have confusion matrix to see how many predictions we have correctly made, and then we have different model comparison techniques. I'll see quickly. Are there any new questions? I don't see here. Okay. Please raise any doubts so that I would be more than happy to explain. And feel free. Every question is important, because that will help you understand this industry, because this is a very exciting industry, and you should have many questions. And typically questions comes after the seminar. So just make sure you just wrap it up and send it right now, so that I will be able to answer. Again, before I have termed this way, before we do fancy DS stuff, linear algebra is very important, because once you start dealing with lot of huge data set, you have to customize your algorithm, and you should be familiar with vector methods, and linear algebra will take you a long way. It's not only it will help you in your designing your algorithms and machine learning, but linear algebra and this vector method will also help you in say future machine learning, AI, say don't survive, right? Say may they go through the what we call it as AI winter, right? And but you might, this knowledge of linear algebra and vector method will be still helpful for doing financial data analysis and stuff. Practice working with Python Flask. Flask is like a web API which you can build and present your outputs. Backend technologies such as TensorFlow and PyTorch will be very much helpful if you practice. TensorFlow seems very confusing or intimidating, but TensorFlow is nothing but if I replace the word tensor with multi-dimensional array, I think this will make you feel that okay, this is nothing more than multi-dimensional array, which is nothing but NumPy ND array when you call it, right? Just that multi-dimensional array has been smartly processed in TensorFlow, so we call it as a tensor, but tensor is nothing but a multi-dimensional array. So don't get scared with those terms and terminologies. We have to be very good with linear optimization. Linear optimization, one of the example is, suppose I have to produce say 100 car in a day, and I have say 10 resources. So what is the best way I can utilize my resources so that I can have maximum productivity and cost reduced and efficiency? So linear optimization helps you with those. These are very interesting areas to solve and learn, and this kind of knowledge is helpful not only in machine learning or data science, but also as a business analyst and other areas. You will find this applicable to those areas as well. And Understanding a mathematics in deep learning, I will say take it as a hobby reading. You don't have to focus entirely on getting into the mathematical part, because for example, if I have to do and build an Android app, I definitely have to use Java or Python, but then I don't have to actually understand internally how Java works. Maybe if I have to make super efficient app, maybe eventually I would need to understand how Java interacts with the hardware. But then at the initially you don't have to, but because these things does take a long time to learn. So I would say make a habit of reading maybe few slides or few concepts a day, just to get a complete understanding how these things work internally. Technical, I was explaining, make sure that you practice well with your XGBoost library, because nowadays in most of the Kaggle competitions, people use XGBoost library to solve their problems. And for deep learning, I personally prefer the Keras framework. Sorry, spelling mistake. I use Keras framework with the TensorFlow background, but you do not have to use TensorFlow. If you're familiar with Caffe, MXNet, or PyTorch, CNTK, you're more than welcome to use anything as a backend, and they all work with Python. So this knowledge will, because nowadays, even deep learning solution, people are building it in a days rather than months or weeks, because there are a lot of framework already available. Just don't try to get too much into the details of, eventually we'll have to, but whenever you're learning something, just see how those tools work. Okay, you don't have to, for example, if you want to cut an apple with a knife, don't go into trying to see how a knife is built on the first place, right? Just understand how a knife, you have to safely use a knife. That's it. Once you have interest over the time, and then you can see how a knife is built in a forge shop, right? And then you try to, many people will try to explain you that get into the too much of the basics first, but then in this world of machine learning, you are an engineer, you have to find the fastest and the quickest way to solve a problem rather than getting too much into the basics. Unless it is nothing is available in that area which you can use, then obviously you have to spend time to research and build an algorithm and tool. But other than that, there are pretty much smarter people who have built lot many libraries and framework, and it's good idea to rather use them first and then see whether it suits your purpose or not. Many times it will, and only in few occasions it might not, and you might have to set up your own R&D team. Okay, so these are the in short the entire. I would have tried my best to provide you with as much as information as possible in this area of BFSI. So if you are interested in getting into the BFSI as a machine learning engineer or a deep learning engineer, I would say I will definitely share this slide. Just make sure you're familiar with this. Not, you have to not know everything, but at least whatever you know it really well, and you know how to use it well. So that will take you a long way in this industry. Also, technical things are just enablers, but you have to more or less. I think a couple of days back, I was telling somebody that you have to know the psychology behind it. You have to study about human psychology, why a customer would do this and not that. So you have to be able to understand those things, and then you take technology and try to implement it, not vice versa. Your technology is as good as what we ask it to do. So depending on technology for your answers may not be the best way. Rather, you have to first understand the logic and the business problem, try to solve it manually and see whether you can do it or not, and then you apply technology to make your life easier, not vice versa. Any questions so far? So Arga, that's all I had to cover in the in this area, BFSI. I remember I have made a lot of additions compared to the previous module that I did, and it has a lot of information in today's session, but I have not seen any more questions so far.
Yeah, because no more questions as such.
Okay, so I'm happy to, if you have any questions, I'm happy to see that in my email, and I would definitely respond to it. For the time being, I will share this PPT with you so that you can distribute it with your students, right?
Yeah, sure.
And I think we have not answered just one question, and that is from Kumar Nityanand. I requested for, I'll still try to answer his question. So
yeah, sure.
his question is, can you make us familiar with important technical terms of insurance domain and its basic technical workflow? So nowadays, if I tell from a machine learning perspective, what we do is we have the insurance data of a customer, in a relational database. Okay, that will have the location of that person, the age, the income group, the company that person is working with, and a few other areas such as habits, whether that person smokes or not. Sometimes people casually give a wrong answer, so sometimes we'll use it, sometimes we'll not. So typically the data set will be stored in a relational database, and then on top of it we have an AI algorithm, and those predictions are then checked by our medical team, which confirms whether that was a fake or not. And that's how somewhere around 1 million or 2 million such claims were manually studied and classified. Whether they, classified, when I say, means whether it was a spam or a fake claim or a genuine claim, and that is used as a supervised labeled trained data. Okay, now in an insurance company, whenever there is a new and claim, that new record is getting passed through the model that we have created, and then we predict whether that was a genuine case or not. So we are very much careful about the false positive and the true negatives, just to make sure that we safeguard our customer data, and we are not just simply ignoring their request for claim. So that is in general we do in terms of whenever we have insurance data to process. But then I was interested more to know what exactly Nityanand is hoping to listen to. So Arga, that's all from my side. I would be happy if you can continue from there.
Sure. Sure, Vikash. We'll just end the session over here. You can forward me the PPT so that I can forward it to the learners. And in case if they reach out to me for any question, I will forward it to you over mail.
Sure, absolutely. I'll do it right away after this call. I'll forward the PPT with you, and then you can distribute it. Yeah.
Sure, okay. Sure, Vikash. Okay, thank you.
Okay. Thanks everyone, and all the best.